All right, so this is the second video for section 13-2 in accelerated geometry. Today we're going to be focusing on dividing rational expressions. If you remember, the video from the day before was on multiplying rational expressions. And just like multiplying rational expressions is very similar to multiplying fractions, dividing rational expressions is also very similar to dividing fractions. So it made sense to me if we practiced dividing some fractions here. So I picked really two very simple ones. If I have 1/2 divided by 3/4, if you remember, the way that we divide by a fraction, in this case 3/4, is to actually multiply by its reciprocal. So that problem is really 1/2 times 4/3. And then you would cancel out any common factors between numerators and denominators. And then you would multiply straight across the numerators and straight across the denominators. So 1 times 2 is 2. 1 times 3 is 3. So 1/2 divided by 3/4 is equal to 2/3. So, like I said, dividing fractions dividing rational expressions works the exact same way. For example, here we have 5x to the 4th divided over 8x squared y squared. I can't talk today. And my pen's not going to work. There we go. And we're dividing that by 15 over 8y to the 5th. So this is actually 5x to the 4th over 8x squared y squared times 8y to the 5th over 15. And now at this point, it becomes just like the problems we did yesterday. We cancel out things that are in common between numerators and denominators. This can reduce to a 3, and this reduces to a 1. This will reduce to an x squared, and this will reduce to a y cubed. So left across the top, I have 1 times x squared times y cubed. So that is x squared y cubed. And in the denominator, everything is canceled except for this 3 right here. So that final answer is x squared y cubed all over 3. And just like I said yesterday, you did not have to be able to simplify as easily as I did all at the beginning there. You could have canceled out the 8s, left the 5 alone, and had 5x to the 4th, y to the 5th, over 15 x squared y squared. And then once you get it into single fraction like that, it's a little bit easier to see that 5 over 15 reduces to 1/3. X to the 4th over x squared is x squared, and y to the 5th over y squared is y cubed. So see, I got the exact same answer. You probably have less chance of making a mistake if you do it the second method. So let's look at another one here. I have x to the 4th minus 9x squared divided over x squared minus 4x plus 3 divided by x to the 4th plus 2x cubed minus 8x squared over x squared minus 16. So the first thing that I'm going to do is I'm going to rewrite that as a multiplication problem. So x to the 4th minus 9x squared over x squared minus 4x plus 3. And then that's times x squared minus 16 over x to the 4th plus 2x cubed minus 8x squared. And so at this point, before we start multiplying things, we want to factor everything to see if there's any common factors we can go ahead and cancel out. So x to the 4th minus 9x squared, I can factor an x squared out of both of those terms, which leaves me with x squared minus 9. But that is also factorable into x plus 3 times x minus 3. And at this point, I'm not going through all the steps of how to factor these. You guys should know how to factor these at this point. So I'm going to cut to the chase pretty quickly here. X squared minus 4x plus 3 factors to x minus 3 times x minus 1. So if you're still confused as to how some of these factors, that means you need to come in for extra help and see your teacher and ask some questions. X squared minus 16 factors to x plus 4 times x minus 4. X to the fourth plus 2x cubed minus 8x squared has a greatest common factor of x squared. And then what's left factors to x plus 4 times x minus 2. Common factors: x squared, x minus 3, x plus 4. So that leaves me with x plus 3 times x minus 4 all over x minus 1 times x minus 2. That technically is the correct answer, but I would suggest that you take the time to FOIL those out. And so you get x squared minus x minus 12 over x squared minus 3x plus 2. That's the answer I'm going to be looking for. Distribute whatever is left. Okay, so I want you to pause the video. Oh my God, I'm not recording. Okay, so I want you to pause the video for a few minutes, and I want you to work number 3 and number 4. Okay, so let's look here. On number 3, you should have hopefully taken the reciprocal of the second expression, and then when you multiplied everything through and simplified, you should have ended up with 3y over x squared for your answer. And if you need to pause the video at this point to look at my work and write some stuff down, definitely go ahead and do that. On number 4, I took the reciprocal of the second expression, and then I factored everything. Notice there's a lot of common factors here, and the only things left that weren't common anywhere were 4 times x minus 4 in the numerator and x plus 3 in the denominator. So that leaves us with 4x minus 16 over x plus 3. Okay, so that kind of covers dividing. It's really the same as yesterday, except you have to flip that second fraction first. So now let's talk about solving rational equations. For number 5 here, I have x squared minus 25 over x minus 5 is equal to 14. Now some of you at this moment may be inclined to try to take the x minus 5 and multiply it over to the 14 so that we don't have a fraction anymore. That's certainly a possibility, but my personal suggestion is to try to simplify this expression before you do any moving stuff to the other side or anything like that. And by simplifying it, I mean taking out any common factors, which would mean that we would need to take the numerator, x squared minus 25, and then look at what happens if I factor that to x plus 5 times x minus 5. Now notice I have a common factor in my numerator and my denominator. That common factor can cancel out, and now my somewhat difficult problem is now something you could have solved in middle school. X plus 5 equals 14. Well, if x plus 5 equals 14, you subtract 5 from both sides, and you would get x equals 9. So now you're thinking that that's your answer, and it probably is, but notice up here the directions said to check your solution. Please, 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 please do that. And what it means by that is, remember with a rational expression, what can we never have in the denominator? It can never equal 0. So really all you're doing is you need to take that answer that you get and just double check that it would not make the denominator equal 0. So if I substitute the 9 in, I get 4, which is not 0. So it's good to go. So x equals 9 is an acceptable answer. So now let's try that with number 6, and I left off what it was equal to. It is equal to 7. So if we're going to solve that, the first thing I would want to do is factor the numerator. It factors into x plus 5 times x minus 2. All of that is over x minus 2, and it equals 7. So notice my common factor is x minus 2. So I have x plus 5 equals 7. X equals 2 is what I think my answer is. So now I'm going to check that one. So I'm going to take it and substitute it into my denominator and make sure that it does not give me 0. Well, unfortunately, it does give me 0. So this cannot be an answer. And so since I don't have any options now for my answer is no solution. There is no time where this expression is equal to 7. All right, so I want you to take a minute, pause the video again, try number 7 and number 8. Okay, so on number 7, the numerator should have factored to x plus 4 times x minus 3, which leaves you with a simple equation of x minus 3 equals negative 7. And when you solve that, you get x equals negative 4. However, when you go and substitute negative 4 back into your denominator, you have negative 4 plus 4, which is 0. And we cannot have 0 in the denominator. Therefore, our final answer for number 7 should be no solution. That is why you have to check your answers. Then on number 8, 4x squared minus 9 factors to 2x plus 3 times 2x minus 3. So the 2x plus 3 is your common factor. You're left with 2x minus 3 equals 5. And when you solve that, you get x equals 4. Substituting that into the denominator, you get 11, not 0, which is good. So our actual answer for number 8 can be x equals 4. All right, I hope the dividing and the solving is making sense to you. You'll get some more practice on it in class tomorrow.